Hello guys, my name is Hayden Bird, and today I am giving my report on the charged tape experiment. For those following along, you can find my GlowScript code in the bio of my YouTube video. To start off, I would like to introduce this experiment. The purpose of this experiment was to allow us to apply Coulomb's law and the electric force equation when dealing with charge, giving us the ability to observe fundamental forces such as conductive electrons transferring surfaces when exposed to a charge. The problem this experiment would like us to answer are how much excess charge can be measured on a piece of tape after contact with charged Scotch tape, as well as what fraction of the atoms would give up electrons in the process. You were able to use various amounts of physics concepts to answer these problems. The physics concept I use when answering this experiment is Newton's third law of attraction, also known as the equal and opposite forces attract, while like forces repel. Coulomb's law to measure the extent of which the electric forces repel, as well as the electric force equation, which allows us to calculate charge. A brief debrief of the results was after the interactions between the charged tapes, the sample piece had a positive charge of 3.17 e to the negative 7 coulombs, while there was an electron deficit of 5.07 e to the 27 electrons. And to the right, you can see an image of the experiment result. The reason we use these specific models when addressing this experiment is that Newton's third law explains that opposite forces attract and like forces repel. Considering two tapes in this experiment have equal and similar signs, they are bound to repel. Coulomb's law, as well as the electric force equation, helps us measure the extent of Newton's third law by allowing us to calculate both the charge and the magnitude of the forces. I originally hypothesized that because the two tapes have similar charges, they will repel. However, that since they're not touching, I did not initially believe electrons would be able to transover because there was no physical contact between the tapes. However, if one of the charged tapes met in a neutral tape, the neutral tape would either give or receive conduction electrons and will require a charge because of the positive side of the dipoles on the tape, which is supported by Newton's third law that states that opposites attract. The materials on the right are what you will need for this experiment, and along with the pictures detailing instructions of what you'll need to do to assemble the tapes and acquire a charge. The system in this experiment is identified as the charged pieces of tapes, while the surrounding is the room that the experiment is taking place in. It is important to make sure that your surroundings are not too humid, otherwise this experiment may not work. Here are the initial conditions that I used for the experiment. Each of the values you see here derive from the instructions given to us when conducting this experiment. With these given values, I was able to find the listed results, which are the final four on the bottom. I will detail each of these results when we get to the coding section of this report. However, in order to find the magnitude of the forces and excess electrons, I needed to find the number of atoms present on the tape, which you can see as the equation to the right. I also needed to acknowledge excess electrons by dividing the charge of tape by the charge of each electron. Before diving into the code, I would like to address the discrepancies that could have happened during this experiment. Systematic errors include the charged tape coming into contact with human skin or other neutral objects such as a desk, which would skew the charge of the U tape, which would also affect the final charge as electrons would have transferred and the two charges may or not have repelled. Random errors include potential human error measuring dimensions or tape/distance of attraction, which could have slightly skewed the results. On the right, you are able to observe the code that I used for my GlowScript model. The top section is the constants, which derive from the experiment's given values and the measurements that I took, also known as the initial conditions. The calculations were from the previously aforementioned equations, the electric field equation in experiment, as well as the number of atoms present and acknowledging the excess electron equation. Lastly, in the bottom right, objects allow us to visualize the electric field as well as the systems and the surroundings in the image that will be on the next slide. On the right, you can see a visualization of this experiment as coded in GlowScript. You need to understand that the distance was scaled by 1,000 times for optimal viewing. I also would like you to assume that air resistance is neglected and that the U tape have identical point charges. The upper tape appears to be floating due to the fact that it is repelled by the force of the lower tape, as you can see. In the text section of the GlowScript, you also can find the tape's mass, the gravitational force on the tape, the tape's charge, the number of excess electrons, the number of atoms on the tape surface, and the ratio of excess electrons to the number of atoms. Regarding model predictions, I was correct in the fact that the two tapes would repel for each other because they had like charges. I was incorrect in the fact that I initially predicted that there would not be electrons given up because there was no physical contact. But as you can see from the results and the GlowScript model, they in fact did transfer over. To finish out this report, there are two discussion questions in which I would like to answer. The first being, what if electrons had positive charge and protons had negative charge? How would this affect your observations? While the individual sign of the charged objects would be changed, the observations would not change as the tapes would still repel as long as each tape had the exact same sign as shown in Newton's third law. However, you can argue that the electric field would be different because of the different signs. We know that protons are typically repelling while electrons are attracting in the electric field. The second question is, why is it important to handle the charged tapes as little as possible, and what happens when the charged tapes come into contact with neutral objects? This goes back to what I was saying with my systematic error. Charged tapes either have a deficit or an excess number of electrons, and making contact with a neutral surface would affect the charge, as a neutral object touching charged tape would cause a transfer of electrons, which would skew the data. Limited handling reduces the chances of this happening. Thank you for watching.